Welcome to this explainer. Today we're diving deep into some core concepts from Chapter 31, Instrumentation for Observability Teams. We are breaking down a really critical reality that we all have to face. Modern software systems have simply become way too complex for intuition alone. You just can't guess your way through them anymore. We're going to explore this massive paradigm shift from traditional monitoring to true observability. And more importantly, we'll uncover how observability teams can build a shared language, one that empowers developers to validate their code in production with absolute confidence. Let's really dig into what it actually takes to achieve true production excellence, especially when the systems we're building span thousands of interconnected microservices.
So let's start off with a profound reality check, encapsulated perfectly by Chad Fowler's thought. As AI allows us to ship code faster than ever before, production really becomes the ultimate and frankly the only place where our intent meets reality. The maintenance horizon of code is fundamentally shifting right before our eyes. Think about it. We're in an era where large language models can generate massive, complex pull requests in a matter of seconds. The sheer velocity of software creation is absolutely staggering. But we have to remember something crucial. The code itself is not the system. The system is the highly unique, ever-evolving intersection of that code, your infrastructure, your users, and your data over time. The messy reality of production involves network blips, terrible database queries, completely unexpected user inputs, and sudden, massive traffic spikes. If you can't validate what that AI-generated code is actually doing when it hits that messy reality, well, you aren't really innovating faster. You're literally just accumulating systemic risk faster.
Okay. Here is a quick look at our roadmap for today. 1. The observability paradigm shift. 2. Shattering the 3 pillars. 3. Instrumenting with OpenTelemetry. 4. Managing the telemetry firehose. And finally, 5. AI and the future.
Let's jump right into part 1, the observability paradigm shift.
I want you to forget about traditional monitoring for a second. Monitoring fundamentally relies on known conditions. It's perfectly designed to answer the specific questions you already knew to ask in advance, right? Things like, is CPU usage over 90%? But in modern microservices or serverless architectures, things don't break in predictable ways. They break in highly unpredictable, totally novel ways. True observability is about precision and flexibility. It's about uncovering unknown unknowns. We're talking about those bizarre, highly specific failure modes that you couldn't have possibly predicted, meaning you definitely couldn't have written a dashboard for them in advance. Observability means you have collected enough rich, highly contextual data to figure out exactly why a system is behaving a certain way, even if that specific failure mode has never happened in the entire history of your company. It means you stop reacting to green dashboards while real mysteries just become office folklore, and instead you start actively querying your system to understand its actual reality.
Think of your architecture kind of like a sprawling metropolis at night. If you're just flying over it without having installed any sensors down on the ground, you're really just looking at pretty but entirely meaningless lights. Let's say you see a massive cluster of lights suddenly go dark in one specific district. In the world of traditional monitoring, that is exactly like seeing a CPU spike on a high-level dashboard. It tells you that something is wrong, sure, but without street-level traffic sensors, utility meters, and population monitors, you have absolutely no idea what actually caused it. Was that darkness caused by a massive traffic jam, a catastrophic power grid failure, or maybe just a scheduled parade that blocked the streets? Instrumentation is how we install those critical sensors deep inside our code. It reveals the system from the inside out, which allows us to trace the exact same route our users are experiencing, street by street and service by service.
Moving on to Section 2, Shattering the 3 pillars.
The old 3 pillars model of observability, logs, metrics, and traces, is fundamentally flawed. Why? Because it heavily predefines the questions you are allowed to ask. In this legacy approach, logs, metrics, and traces are treated as entirely separate data types. They get stored in separate databases, you have to use separate query languages to search them, and they even have separate retention policies. So if you see a spike in some aggregate metric, you have to mentally pivot and jump over to a completely different tool just to guess which isolated log line might be related to that spike. It's exhausting, it creates a lot of cognitive load, and it's incredibly inefficient. What we actually need today is a unified storage model. By unifying everything into arbitrarily wide structured events, where a single event might have literally 100 key value pairs of context appended to it without any performance hit, you stop pre-aggregating away all your critical details. You keep the raw context completely intact so you can slice and dice the data however you need to later on.
And the power of unifying telemetry into these arbitrarily wide structured events is that it captures all the rich context necessary to answer any future question. When an event happens in your system, you shouldn't just record a basic string of text saying, hey, a page loaded. No, you want to record the service name, the exact build ID, the specific user tenant ID, which feature flags were active at that exact millisecond, the normalized database query, and maybe even proxies for the user's intended outcome, like how many items were in their shopping cart. Suddenly, when an error rate spikes, you aren't guessing anymore. You can just query your data and instantly see, oh wow, 100% of these errors share this exact same feature flag. They all belong to our free tier users, and they were all executed on this one specific build version. It completely levels the playing field. Anyone, from a brand new junior developer all the way up to a staff engineer, can debug the system from first principles.
So how do we generate this data? That brings us to Section 3, Instrumenting with OpenTelemetry.
Automatic instrumentation is fantastic because it gives you immediate visibility into the technical plumbing. It handles your HTTP requests, your database connections, your cache hits. It basically forms the skeleton of your observability. But to get real value, you absolutely need custom instrumentation to capture the specific business logic that actually matters to your product. You need to add the muscle to that skeleton. And this is exactly where an observability team's true North Star comes into play, as highlighted in Chapter 31, Building a Shared Language. Through OpenTelemetry's semantic conventions, which you'll often hear called SAMConf, teams can define standard, human-readable definitions for software concepts. For example, instead of one team over here logging status and another team over there logging resp_ code, semantic conventions dictate that everyone uses a standardized attribute like http.statuscode. This completely standardizes your vocabulary. It makes telemetry a trainable, repeatable skill across any tech stack you have. Whether you're writing in Java, .NET, or Swift, everyone is speaking the exact same dialect when they add that custom muscle to the code base.
But all this brings up a really fascinating structural question, one that completely transforms how engineering organizations must operate. If we need all this custom muscle to capture business logic, and we have this strict shared language to follow, who is actually typing the code? Who is ultimately responsible for ensuring that the telemetry genuinely reflects the reality of the application?
The answer is, the software engineers who write the code must own the instrumentation. It is a fundamental product decision, not just an operations or an infrastructure task you can hand off. Instrumentation is quite literally how your code reports back to you to validate your intent in production. But wait, if developers own the instrumentation, what exactly does the observability team own? Well, they own the platform. The observability team shouldn't be trying to instrument every single microservice themselves. That simply doesn't scale in any modern enterprise. Instead, they act as the architects of this shared language. They build the underlying libraries, they standardize the naming schemes, and they provide the overarching frameworks. Think of the observability team as a master guide on a really grueling mountain climb. They might not be the ones physically taking the picture at the summit, but they build the safe, repeatable paths, they install the ropes, and they provide the gear to ensure absolutely nobody falls off the mountain on the way up.
Now let's talk about what happens when this data starts flowing. Section 4. Managing the telemetry firehose. Once your developers start properly instrumenting everything, you are going to generate a massive firehose of data. To safely manage this volume, you need a dedicated telemetry pipeline. You usually begin by pointing a brand new greenfield app to a pipeline control plane, which functions as your collector and router. By actively decoupling your instrumentation from your backend storage, you give yourself some incredible architectural flexibility. For instance, you can alter data reduction strategies at runtime without ever having to redeploy your code. You can filter out sensitive, personally identifiable information right at the edge. Or you could strategically route specific high-value billing events to a secure long-term audit log while simultaneously sending your high-volume performance traces over to your daily analysis and debugging tools. It's incredibly powerful because it puts the control of that firehose directly back into the hands of the engineers.
But you don't have to boil the ocean to achieve this setup. It's best to follow a pragmatic, phased path to adoption. This delivers early wins without disrupting your critical legacy flows. You start with just a single greenfield microservice. You validate the pipeline end-to-end with that one app. You establish your semantic conventions and make sure the data looks exactly how you want it to in your backend. Then, and only then, do you slowly and incrementally redirect your existing legacy agents into this new centralized gateway. This approach is also incredibly vital for highly secure regulated environments. In regulated spaces, observability inherently creates a deep tension. Its whole superpower is correlating data across boundaries, but that correlation can heavily threaten strict security isolation. So by using a centrally managed pipeline and a strictly defined shared language, you can actually facilitate deep compliance. You provide exact, filtered evidence to auditors, completely without compromising your strict security boundaries.
Now, to control your telemetry costs in a high-volume environment, you must choose your sampling strategy wisely. You have to balance data fidelity with your specific resource constraints, because, let's face it, not all data is equally valuable to your business. Let's look at head sampling first. Head sampling makes a random algorithmic keep-or-drop decision the exact moment a request starts. It is incredibly cheap computationally, and it's great for high-volume, uniform traffic where every request basically looks the same. Tail sampling, on the other hand, is much more sophisticated. It waits until the entire trace is completely finished before deciding whether to keep it or drop it. Naturally, this requires significantly more memory because it has to temporarily buffer all that trace state while it waits for the request to conclude. But that buffering is totally worth it. It guarantees that you dynamically capture 100% of your rare errors, your agonizingly slow requests, and your bizarre anomalies, while aggressively discarding the boring, successful, everyday traffic. Choosing the right strategy depends entirely on your unique business goals and your infrastructure budget.
Finally, let's look at where all of this is heading in Section 5, AI and the future. Your observability team shouldn't exist just to build dashboards for other people. In fact, they must build the platform that makes manual dashboarding entirely obsolete. Their ultimate mission is to make it utterly effortless for every single engineer in the organization to understand exactly what their code is doing in production in real time. Achieving this requires a true product engineering mindset. It means treating your internal developers as your absolute most important customers. You need to provide beautifully paid paths for them to walk down, ensuring that auto-instrumentation feels like absolute magic straight out of the box. By reducing their cognitive load, you empower them to focus on what actually matters, solving real business problems.
And we are rapidly reaching a fascinating point in the industry where AI agents can actually assist in planning and adding this vital instrumentation directly into your codebase, ensuring that best practices are uniformly followed. Think about the emerging copilot model in software engineering, right? An AI agent can look at a pull request, identify missing semantic conventions based on your observability team's strict definitions, and then automatically inject the proper, well-named OpenTelemetry spans. The AI uses the shared language you've meticulously built to perfectly capture the developer's exact intent, and it does this before the code even merges into the main branch. It effectively acts as an automated quality gate for your telemetry.
Because as AI drastically lowers the friction and the time required to write code, true observability becomes the primary safety mechanism preventing that increased speed from just degrading into systemic risk. In the AI era, competitive advantage is no longer about how many lines of code you can churn out in a sprint. It's entirely about how quickly you can validate that code, deeply understand its impact in the real messy world of production, and iteratively learn from it. Rich, arbitrarily wide events packed with full context act as the ultimate guardrails for these automated coding techniques. They ensure that your speed never, ever comes at the cost of stability or customer trust.
So I want to leave you with this provocative thought to deeply consider regarding your own systems in your own engineering culture. In the blistering speed of the AI era, if an AI agent generates 1,000 lines of code today, will your team know exactly what it's doing in production tomorrow? Without a robust, shared language of instrumentation, and without treating observability as a core product requirement, you are flying completely blind into the future. Thank you so much for joining this explainer. I really hope this deep dive helps you take those vital first steps toward achieving true production excellence in your own organization.